Hi, and welcome to this section on Terraform outputs and data sources. So far in this chapter, we've covered a provider, resources, TF vars and variables, and in the last section, we used the back end to transfer our TF state into S3. Now, we're going to expand this model even further by adding outputs and data sources. Those of you who are already experts in Terraform and are presumably watching this for the sheer entertainment value alone, may at this point be raising an eyebrow and questioning the accuracy of my diagram here. And yes, well raised that eyebrow, for in fact, data sources do not really just draw data from backends as I've indicated here, but from a whole host of other locations, such as external sources, null sources, templates, plus loads of things from the provider itself. But as you can see, this upsets the feng shui of my diagram no end. Aside from aesthetic reasons, it's also the case that we will be focusing on a single type of data in this section, that of the Terraform remote state, which actually is drawn from the data in the TF state and has previously been placed there by an output. I've chosen this as it's a prolifically used method that spans most provider types and is also conceptually one of the most useful. The format remains pretty much the same in any case, so we can afford to be specific, and I can afford to keep my diagram in harmonious balance without too much guilt. Let's split that stack of resources out into a simple case of just two, A and B. When resource B is applied, it generates an output, which is given a name and stored in its TF state file. When resource A is applied, the data source has been configured to read the TF state and take the information in the output for use in its own code. I have an unhealthy obsession with drawing diagrams, but this is one of the few situations I have to admit that it's actually easier to understand by looking at the code, rather than pictures. So let's jump straight into creating an example to see more clearly what's going on. Like the previous sections, all the code in this section can be cloned from the Lernard Git repository, for which you can find the link at the bottom of this player. As always, let's cd into our Terraform repo here, list out the contents, and, you guessed it, copy section 6 to section 7. You can see here the files we created in the last section are, as usual, all just loose in the section 7 folder. But this section, we're going to do something a bit different and create two folders, using makedir to make component A and component B. These simulate two different but isolated Terraform configurations. Terraform sometimes calls all the configuration in a single folder a module, which we're going to have a look at in an entire section dedicated to this next. But for now, you don't really need to worry about that. It's just worth knowing that Terraform never recurses content, by which I mean it doesn't go digging around in all the subdirectories adding together all the .tf files to run. It always remains in the folder you start in, unless explicitly told to look for something elsewhere. Right, let's jump into Visual Studio Code and open the Terraform folder. I'm going to open my section 7 directory and make a copy of all the files into each of the component folders. We'll do backend, now main, now provider, TF vars, and now variables. Now that's done, we're going to delete all these files from the root. So now we're left with two identical sets of Terraform files, one in each component folder. Also, as always, let's delete the .terraform folder that's left over from the last section. Now we want to remove all references to section 6 in each component. In component A, I'm going to search for section 6 and replace it with section 7A. There we go. And now let's do the same for section B. Okay, great. Also, in the last section, we changed our count to 3 to illustrate something or other, but we don't need all that clutter now, so let's just change it back to 1. Okay, that was a big cleanup, but now we're ready to create our features. I realised I could have all this pre-made and still illustrate the same points to you, but I find when I learn, what really cements stuff in my head is repetition and doing. Every time building on something a little bit more. I once went for a job interview that I'd been warned had a particularly hard technical test in Terraform. To prepare for this, every morning I got up before breakfast and recreated my own personal Terraform infrastructure from scratch into a blank folder from memory. What I found amazing was that having done Terraform for years beforehand, I still didn't know loads of the syntax off by heart completely. I'd actually been copying and pasting from previous work all those years without remembering. The interview turned out to be nowhere near that hard, but the exercise is a really good way to improve your understanding of each of the Terraform parts. Start with a blank page and see how far you can get without help or referencing the internet every single day for a month. Anyway, let's start on component B here by opening main.tf and deleting everything inside it. Now we're going to make a single security group inside here. Which I'll call allow TLS. For those of you not familiar with the term, a security group is an AWS brand name for a firewall. It has incoming and outgoing ports that can be whitelisted, just like a normal firewall, and instances can be associated or attached to security groups to give them that level of security, just like an ordinary firewall. I'm going to give it a pretty classic setup here. We'll give it the name allow_TLS and a similar description. I'll use the word ingress for ports that will be open for incoming traffic, and now specify only HTTPS traffic will be allowed through this, with a from port of 443 and a to port of 443. The protocol is going to be TCP, and this CIDR blocks option is for if we want to lock this down to a particular network. For those of you not familiar with networking, 0.0.0.0 means everywhere. So I'm saying this rule applies to traffic from everywhere. Great! A standard setup for an HTTPS firewall then. Now, in component B, just like in the diagram intro, I'm going to create an output. So I'll make a file called output.tf. We'll write the word output, and I'm going to choose to output the security group's ID. So I'm going to call this security group ID. The data that goes into an output is specified using the option value, and then we can identify our resource in a normal way by writing AWS security group, its name, allow TLS, and then .id, because this is the value we're going to need. Just to confirm, as with referencing an instance, the name Terraform is interested in this case is the name defined in the resource first line, which is the Terraform internal name. There's also an option for a name below, just like we name the instance with tags, but this is the name AWS will use. So when referencing components using Terraform, you always use the first defined name at the top. These names generally can't be interpolated, so for example, I can't use a variable or calculated name in this place in most cases. I have to actually write it. Right, so there's our output anyway. Now let's create a data source in component A in a file called data.tf. First we write the word data, as you might expect, and now, as I mentioned, because there's lots of different types of data source, we need to say which one we want. In this case, that's going to be Terraform_remote_state. And we're going to call this component B. 2 curly brackets for the options block, and we need to specify that the state we want to read is S3. Then we open a config block to give it the details of where this backend actually is. So the bucket is Lernard backend, as this hasn't changed and we're storing all of our TF state files in there. Importantly here though, the key is section 7b. This is a point that the whole next section is going to cover, as I mentioned, in more depth, as it relates to modules. But at this point, I just want to draw attention to the fact that due to our find and replace earlier, the file names for the TF state keys for component A and component B are different and do not interfere with each other. Some of you may have been wondering, what's the point of all this output and data malarkey then, when earlier in this chapter we just wrote AWS instance.name.id directly for an implicit dependency without having to export it as an output nor import it as data. And yes, well spotted, that is true. The key difference to understand here is that outputs and data are required when consuming Terraform that was created in a different folder, and so either belongs to a child module or has a different TF state file entirely, as in this case. Component A has a TF state file named section7a, but we are consuming a value in this data source in a TF state file named section7b, and so that's why we can't directly access the resource and need to use a data and output. Okay, let's open our main.tf file and make some changes here. We'll delete the bucket and the elastic IP as we don't need those for this demo. And now, in the instance definition, add a new option called vpc_security_group_IDs. This option attaches a specific security group to our instance. Open a set of square brackets, and now we're going to use our defined data source as the source of the ID we need for the attachment. So in this case, we're going to write data.terraform_remote_state.component_b.outputs.security_group_IDs. It's a bit of a mouthful. Let's recap what we've done here then. We've defined a data source in component A, which consumes an output we've defined in component B, and then we've used that information to attach the security group in B to the instance in A. I'll just neaten this up a little bit here. Right, let's hop back into the terminal and take all this for a little spin. First, we need to spin up component B so that it can populate its TF state with the security group ID. So, cd into the component B folder, and now Terraform init. Now the plugins are downloaded, let's Terraform plan. And as expected, there's only one thing to spin up, so we can go ahead and apply it. Notice that because we have an output defined in what Terraform considers to be the root module, i.e. the one that we're in, it is declaring that output on the terminal. So you can see here it's saying security group ID is yada yada yada. That's not something we need to use particularly, but it does at least show us that our output has worked, as expected, and that the ID is now available in TF state. Let's cd into component A, and again, Terraform init, Terraform plan, and Terraform apply. As this is applying, the data source is reading that TF state in component B, taking that security group out, and using it to attach to the instance we're creating. Now that's done, as usual we want to go and check out that it's actually worked. So let's switch to Firefox, browse to the AWS console, and go to EC2 instances. You can see down here on the right that under security groups in details, there is a security group labelled allow TLS attached. And clicking through to it confirms it's got all the details of the group we've created. So that's it. Outputs output things, and data brings in stuff from external data sources. A couple of things I'd like to underline here. Firstly, Terraform remote state data sources like the one we've used here are most commonly used for passing data between modules, which we're going to be covering a lot in the last section. Also, there are lots of different places you can import data from, as I mentioned in the intro, so do have a play around if you're feeling bored. I can particularly recommend having a look at the template data source as a useful one. So, as always, the last thing we're going to do is destroy our infrastructure with Terraform destroy. And again for component B, remember it will only destroy stuff that's defined in the folder that we're in. Finally, back to the root folder of the repo, and git status, git add a sensible commit message, and then push back to master. Okay, another section down. In this section, we took a look at outputs, outputting things into the TF state, and we took a look at data sources, reading stuff from that TF state. Now, I did say during this section that the primary use case of this is going to be when we start using modules, so we're going to take a look at that in the next and final section. Hopefully see you there.